In this video, we're going to finish up this example. I numbered them, and I still finished when I got down to number 1. We had number 2 and number 3, so we'll work those now. It says find the angle between the two lines as they intersect. So let's write some notes here. Angles between lines is the same thing as angles between their directional vectors. Okay, so if I want to find the angle between, I'm just going to use my angle between vectors formula with v1 and v2. All right, there we go. So we need those things. I like to figure them out off to the side and then plug them in. So we'll dot them first, v1 and v2. Let me zoom out to get those vectors that are up there. All right, so dotting those, all right, we got 12 plus 6 minus 16. Okay, let me zoom back in. All right, that's going to end up to be 18 minus, it's 2. So the dot product's 2. Let's go ahead and find the magnitude of v1. Okay, v1 was, if I go back up, it's the square root of, okay, v1 was right here. So 1 squared is 1, 6 squared is 36, is 37, plus 4 more is 41. So v1 is the square root of 41, magnitude. v2's magnitude, if I go back up, we're looking right here. 144 plus 1 is 145. 145 plus 64 is 209. So this is the square root of 209. So to find the angle, cosine theta equals, okay, what do we got? 2 on the bottom, and then I'm going to take 41 and times it by 209, and then throw that under a radical. Okay, we don't get a pretty number, so I'm going to leave it the square root of that big number when they multiply 8569. 8569. So to find theta now, we just find the inverse cosine of that number. All right, the approximation for that, calculator, hold on. Okay, there we go. Inverse cosine of 2 over the square root of 8569. All right, I got about 1.549 radians, which is roughly times 180 divided by pi is about 88.8 degrees. All right, that was problem 2 off that example. Now we got to do 3. 3 says, also find where line 2 crosses the coordinate planes. All right, so to find this, let me add a page to this. All right. Crossing the coordinate planes. Okay, what I mean by coordinate planes are like the XY plane, XZ plane, and the YZ plane. Okay, so for 3, I'm going to write the directions here. Find crossing of coordinate planes. Okay, do XY plane. All right, to do the XY plane, we let Z equal 0. If Z goes to 0, all right, then we got to go back up. Let's L2. So if I go to L2 and I let Z equal 0, okay, well, Z in this case, let me write this in a different color so it's a little, this is equal to T. So if I do solve for Z, 14 equals 8T, then Z2 equals 8T plus 14. So if I let Z equal 0, then I get z equals, oh, actually we could have done it right here. Could have done it right there. All right, if I let z equal 0, so let's do that. I get 0 equals, or 0 minus 14 equals, is it 8? Sorry, my brain, 8t. Yep, there we go. Which tells me that t is equal to negative 7 over 4. This is t2. So I just plug in all those now for my z, or for my equation, for my L2. So if I plug in t, okay, one I'm going to read. Let's rewrite these equations real quick. They're right here, I think. Yep. And let me do this. I'm going to copy this and bring it down so I can quit scrolling. There we go. Okay. So these are what we came up with earlier. This was x equals that. Oh, I grabbed t1. I meant to grab t2. Okay, let's do that again because we're dealing with L2. So L2 was this side. So I'm going to grab that. This was solving each equation. So this is x equals, struggling with my iPad, I guess. X equals, y equals, z equals. That was that line. And we're letting z equals 0, and then we're plugging in t2, which is negative 7/4. So x equals 12 times negative 7/4 minus 7. I'm just going to use my calculator. I got negative 28. Do the same thing for y, so that's negative 7 over 4 plus 3. That's 19 over 4. All right, so that's 8 times negative 7 over 4. 7 over 4, and then plus 14. Okay, I got 0. So it crosses, and that makes sense because that's where z equals 0. That's how we got the point. So it crosses at negative 28, 19 over 4, and 0. So that's the point it crosses. We got to do the other planes now. We got xz plane. You could probably take a guess at what we're going to let equal 0. It is y. So if I let y equal 0, now I have all this up here. 0 equals negative t2 plus 3. Everything was based off of this for the work that we did right here. It just was a little difficult to get there scrolling back and forth. So this was L2. Okay, so that gets me, this is nice one, t2 equals 3. So I plug in each one. X equals 12 times 3 minus 7. That's 36 minus 7 is 29. Y equals, okay, negative 3 plus 3, which is 0. Makes sense. Z, and then plugging in 3 there, 8 times 3 plus 14. That's going to be 24, 34, 38. So this crosses that axis, this line, at that point. And then we have one more. We have the YZ plane. All right, and we let x equals 0. So I got 0 equals 12t2 minus 7. Okay, that tells me that t2 is equal to 7 over 12. So we got one more thing. We got each one to plug in here. X equals 12 times 7 over 12 minus 7. All right, that makes sense. It's 0. Y is negative 7 over 12 plus 3. Use my calculator. All right, that's 29 over 12. And then Z equals 8 times 7 over 12 plus 14. I got 8 times 7 over 12 plus 14, which is 56 over 3. So that means that this line intersects right there. There we go. So we have the intersection of each point in each plane. It's kind of a neat thing to be able to do. This actually would allow us to graph the line. We could just plot two of these points, really, because we only need 2 points, but we actually have 3 points, and they should all be collinear.